about halfway through my chemical engineering degree, without much of a clue where to go next, I got some advice from my neighbour who worked for an energy company. And he said, why don't you apply for a summer placement with E.ON? This is a company you might have heard of. So I did just that. And in the summer of 2009, I found myself in this gas-fired power station in Lincolnshire. And this was very much the beginning of my career in the energy sector. Before this, I had thought about studying medicine because I wanted some way to contribute to society and I understood what doctors do. But being at this power station, I suddenly realized that I can contribute by working in the energy sector because the electricity that's produced by this power station and others like it flows into transmission cables. And from here, it travels to me and you, and it lights the lights in this room. It powers sockets in people's homes. It pretty much powers everything in our lives that relies on electricity. So from here, I went on to work in more coal and gas-fired power stations. And then I got into oil and gas extraction. And this was very, very exciting. I had amazing colleagues. It was a really fun industry to work in. I got to visit some remote locations like this gas field in the middle of the North Sea. But as the time went on, I felt more and more guilty about being part of this fossil fuel industry. I was learning more about climate change and more about the impact of fossil fuels on the environment. And I looked around me. People that I knew, engineers, were transitioning their career from fossil fuels to renewables. But also at the same time, I justified it to myself because we all use fossil fuels all of the time. It is something that we rely on in today's modern society. So, and it's been like this for forever, really. Well, since the 1700s in the Industrial Revolution, and that was powered by coal. So this is Battersea Power Station in central London. It burned coal to power parts of the city. After that rise of coal, we had that rise of oil, and that really made our world a lot smaller. So oil-powered cars and planes. And it's not that fossil fuels are evil. I really don't think they are. They've given us quite a lot. Without them, maybe the improvements in quality of life that we've had wouldn't have been possible. But we have a lot more knowledge now. We know about the damage that they cause, and we also have other options now. So I really think it's time to say thank you to fossil fuels and let them rest in peace underground where they come from and move on to something else. And actually, testament to that, this power station is now a shopping centre. And for me, every time I see it, it's a physical reminder of our reliance on coal. So it was time for me to move on as well. And I was really struggling with how to leave a job that I enjoy and what to do next. When the problem was kind of solved for me, the part of the company that I worked for was sold, and I was made redundant. So I was suddenly released from this internal fossil fuel prison that I was inside. And thinking about all of this, I realized that I knew lots about bits of the energy sector, but not that overall picture. It was a bit like I knew my way around different parts of Newcastle, but I'd never seen the map of the city. So to remedy that, I eventually got a job with the UK government's energy department. So from 2018 to 22, I worked with the Energy Innovation team at the Department for Business, Energy and Industrial Strategy. And in that time, I started to really get that overall picture and connect all the dots as well. So I saw how we generate energy from different sources, how we move it around the country, and how it's used in different sectors. And also, it's all interconnected and global as well. It's not just UK-focused. All of these energy systems connect to each other across the world. And also, quite importantly, I started to see that link between energy and climate change, because in today's world, using energy equals greenhouse gas emissions, and that takes us to climate change. So when I think about such a big problem like the energy transition and climate change, I find it really helpful to break it down. And one way to do that is to look at where the emissions come from, which sectors they come from. So if we look at the UK, this is where the UK's emissions came from in 2021. So you can immediately start pointing fingers at the biggest culprits. There is data like this for other countries as well. They all vary slightly depending on how they operate. But if we stick with the UK for now, so transport is the biggest emitter, or was in 2021. A quarter of emissions come from mainly diesel and petrol-powered personal vehicles. There is a big drive to change this, a big push for electric vehicles. Other countries are pushing ahead with this as well. So over in Norway, there is a massive uptake of electric vehicles. If we manage to solve this, it's a double win. We reduce emissions and improve air quality. So yeah, that would be really great. And closely related to this sector is the electricity generation sector. So a fifth of emissions in the UK came from here. And that was mainly from gas-fired power stations. In the UK, most coal has now retired. Not the case in other parts of the world. Coal has not gone away. In other parts of the world, they still heavily rely on it, but not so much in the UK. I say it's closely related to transport because if you charge an electric vehicle with electricity generated by fossil fuels, you're not really solving the problem. So to clean up transport, we have to clean up electricity generation. And happy to say this is a positive picture for the UK. There's been a huge rise in offshore wind electricity generation. My one disappointment is the lack of onshore wind in this country. If you go over to Denmark, you will see wind turbines all over the land supplying the Danes with clean electricity, and I am very jealous of that. So the next two sectors, business or industry and residential, together account for a third of emissions. And these are very much heat related, so I've stuck them together. If I think about the building that we're in today, it's made from lots of glass, cement and steel, and other materials that were made in a factory. For those industrial processes to work, huge amounts of heat are needed, and we generally get that today by burning fossil fuels. Likewise, if you put up a house, you need all of these materials. And once that building is up, you have to keep it warm in the winter. And that is where our residential emissions are mainly coming from. Most of us have gas boilers in our homes, and that is where those emissions are coming from. This is really tricky to decarbonize because just think about millions of boilers inside people's homes. We have to go in there and do something about that. It's tricky, but we do have lots of options. So first port of call is always energy efficiency. So insulation, double glazing, you stop that heat from leaking out from the building. That means that you don't have to put as much in. And then once you've done that, you can put in an electric heat pump, or hydrogen is also an option. Likewise for industry, efficiency first. Are those industrial processes as efficient as possible? And then after that, we can look at switching from fossil fuels to something more renewable. Again, other countries have issues like this. So in Australia, they have a very large industrial mining sector where a vast proportion of their emissions come from, so they need to think of ways to remedy that. I include this for completeness. It is not very energy sector related, but 11% of emissions come from agriculture, and that's mainly from the farming of ruminant animals, like cows. So if you want to reduce your emissions, a good way of contributing to that is to eat less meat. All of these different boxes, they kind of spill into each other. They don't exist in isolation. So when we think about the energy transition, it has to be looked at as a system and in the context of the existing world as well. We're not working with a blank sheet of paper here. There are already systems in place that we have to adapt. But there was one thing when I worked in government that I came across that cut across a lot of these boxes, and that was hydrogen. So the whispers about this new wonder fuel, hydrogen, were getting louder and louder. And eventually I caved and I left my nice overview job in government, and I've gone back into private industry now, and I work as a hydrogen project developer, green hydrogen project developer. So what is hydrogen? Is it good? Is it bad? I'll start from the very beginning. Hydrogen is the most abundant element in the universe. It can be used as a fuel, and when it's consumed, it doesn't emit carbon dioxide. So that is amazing news, and that is something that we can use to help us to get to net zero emissions. The bad news, and the catch, of course there is one, it usually doesn't exist alone. So we find hydrogen attached to other elements like oxygen to form water, or carbon to form hydrocarbons. So you see methane up there, that is the main component of natural gas. So before I can even think about using hydrogen as a fuel, I first have to claw it away from these other elements, and that requires an energy input. There are two main methods to producing hydrogen today, and you may have heard of blue and green hydrogen. Those colors refer to how it's produced. So blue hydrogen means that we got a fossil fuel and we prized away the hydrogen from the carbon. In that process, carbon dioxide is emitted, so we then have to capture that carbon dioxide and store it for the hydrogen to be low carbon. Green means that I got some water and I zapped it with electricity, and the energy input in that process split the water into hydrogen and oxygen. So for this to make any sense, the electricity used has to be renewable. So to enable large-scale green hydrogen production, I need cheap and abundant renewable electricity. Now that I've produced my hydrogen, I can start to use it to decarbonize those sectors that we saw earlier. So in a future world where hydrogen plays a role in the energy transition, I can use hydrogen in my hydrogen vehicle, or in a hydrogen truck, or hydrogen-powered plane, or I can use it to generate electricity again. Or I could have a furnace, a hydrogen-powered furnace in a glass factory, or a hydrogen boiler in my home to provide the heat. And a lot of governments are starting to put a lot of effort into this now. So in the UK and in the US, the European Union and lots of countries around the world are really supporting the growth of the hydrogen economy. And if things continue along this trajectory, hydrogen is going to play a role in the energy transition. One other benefit is, I should say actually, it should come with a bit of a warning, because it is resource intensive to make. So if I'm making green hydrogen, like I said, I need renewable electricity. If I've got that already, then it makes sense to use that directly rather than making hydrogen and then using the hydrogen for something else. But I obviously believe that it does have its role, because that's why I'm working in that sector. And there are applications where you can't use electricity directly, and hydrogen can be used as an energy store as well. So I can suck up all that renewable electricity, turn it to hydrogen, and store that away and use it later on. So if all the support that we're seeing continues, I think hydrogen is going to work alongside wind and solar and nuclear and lots of other technologies to give us that better and cleaner energy future. That's really key. There isn't one thing that's going to get us there. It's going to be a combination of different things. I feel like the energy sector, as I knew it from 10, 15 years ago, has been picked up and put in a jar, and it's just being shaken up. And I don't really know what's going to come out of the other end. But I think it's going to be something better. There are lots of challenges and lots of changes ahead of us. So we could put up lots of wind turbines, but that's no good if the cables that carry the electricity up and down the country are at full capacity. We can produce green hydrogen, but we need the electricity supply. How are we going to decarbonize everyone's heating? All of these questions are being asked and answered in the background. But I think we will get there. And we have to, I think something that's important to remember is there are already people who work on the existing systems in that fossil fuel world, and we need to bring them along with us. We can't just leave them behind. So I think the people who are part of the energy transition are really important. And people, so us as individuals, we have a role to play as well. We have consumer choices to make. So I think if it's affordable and if it's practical, we can put solar panels on our rooftops. We can choose a low-carbon electricity supplier. We can insulate our homes to stop that valuable heat from leaking out. Or we can play a political role as well. So you can vote for a political party who supports the energy transition. You can write to your local MP about energy issues. And believe it or not, I think if an MP thinks that doing something will get them a vote, I think they're probably going to get behind it. And I think staying informed on the subject is important as well, so education, and that will help you to make informed choices when it comes to energy. So for me, this has been fascinating over the last 12, 13 years. I started on that, at the heights of the wave of fossil fuels before it came crashing down. And now I've been picked up by this new wave of the energy transition. And working in hydrogen right now is a very unique place to be because the industry doesn't quite exist yet. And I'm there shaping it with everybody else that works in the industry. And we're not really sure what it's going to look like at the end. But I think I'll be here for a little while. And in the end, I hope that I can contribute to a more sustainable energy future where everyone has access to clean and affordable energy. Thank you very much for listening.
Thank you for that. Oh, back in. Thank you for that. So you made a point about sort of, I guess, roughly our friends in traditional energy. And aren't they kind of really one of the big blockages from change? Aren't they sort of actively spending quite a lot of money lobbying politicians and doing some such things to do everything possible to preserve their lock on the way we power things, as you would do if you were a profit-making multinational enterprise making billions of, not to go into the whole thing, but...
Yeah. I think we can win over the people who work for those companies, though. And I am seeing a lot of that. So especially younger generations, they don't want to work for fossil fuel companies.
Okay.
They want to work in renewables, which is great. So I think their years are numbered.
Okay, well, yes. Okay, well... You don't want to go there. That's fine.
No. I mean, they'll keep lobbying. They'll keep doing it. But I think we can attract the workforce, and we can encourage the younger generation. We don't really need to encourage them. They already understand this, and they don't want to be working in coal or oil.
Okay. The other thing was that in our discussion about hydrogen, now, was I correct in understanding that? So you mentioned electrical vehicles, and there's obviously a massive push towards electric vehicles, which I'm sure has some benefits in terms of the environment and achieving reducing emissions. Although you rightly point out that if you're just plugging it into an electric network that's largely powered by fossil fuels, then you're effectively just moving the problem to another part of the value chain, right? Now, with hydrogen power, is it that we could actually today power your car if there was a hydrogen petrol station, if you will, and on 100% hydrogen fuel, and it would using the same cars we have today? So why aren't we actually pushing towards that instead of trying to get everyone to replace their cars, trying to build out a massive charging infrastructure, so on and so forth?
So not quite exactly the same cars we have today.
Okay.
There's
always a catch.
hydrogen-powered cars. They
Right.
do exist. There are some of them in this country.
Okay.
I think they're a bit more popular in Germany.
Okay.
But it's the same issue. You need to be able to fill up your car. So
Right.
you need the hydrogen petrol station or hydrogen station,
Sure.
whatever you want to call it.
Yeah.
I think maybe what you're thinking of is around synthetic fuels. So we could take some low carbon hydrogen, combine that with some kind of source of carbon from somewhere and make a synthetic
Okay.
fossil fuel.
Right. And would that synthetic fuel be better, or would it actually be a zero emission fuel?
It depends where you get your raw materials from. So if
Right.
you make your hydrogen through electrolysis
Sure.
with the renewable
Yeah, for new-
electricity,
yep, sure.
and you get your carbon from, I don't know, maybe you capture it from a factory that emits carbon dioxide,
Mm-hmm.
and you combine those two things together, then that, in theory, could work quite well.
Okay.
It's expensive at the moment.
Okay.
But yeah, it is
So
possible.
moving on from that to actually hydrogen-fueled cars with hydrogen-powered engines, I mean, is that something we should be considering over? Because that sounds like it then, assuming the hydrogen, of course, is been created through renewable energy, that sounds to me like a superior solution to the electric vehicles.
I don't know which one's superior. I think they're both options.
Okay.
Yeah, and that maybe we will have both
Okay.
in the future.
Okay.
I think it just depends on what infrastructure you can put in place for the refueling of the cars. So do you charge your car at home?
Mm-hmm.
There are issues with electric vehicle charging that I won't get into.
Yeah.
But yeah, I think that's why I feel like the energy sector is in the jar, because we're trying out all these different things at the moment, and no one is quite sure how it's going to look at the end.
Sure.
One place where hydrogen could make more sense is in heavy goods vehicles, where batteries would just be too heavy for
Right.
you to then be able to put all your goods in and move them around. So
Right.
that's an area of focus for the UK.
And the battery itself also represents an ecological problem,
Yeah.
isn't it? Especially
Yeah,
if you want to start scaling to all vehicles being electrical. So,
There are no perfect solutions. I think we just have to do something that's better than what we do today.
Yasmin, thank you so much. Cheers. Thank you.